Hello students. Hello and welcome to this video. In this video, we will solve question number 211 to 220. The link to download the PDF will be in description, and at the end I will show you how you can download the PDF of my books and maintain the updated copy. Also, I will show you my question answer website where you can come and ask mathematical questions. So without further ado, let's get started. So question 211. Now before I read the question, you look at the question 209 and 211. The difference is power is one more here of 3, and in the denominator we have extra r plus 4. And on the right hand side, obviously, we have n plus 4, and 4 is same, and then we have sigma, it should be, uh, this should be n plus 4 ck, so it will power k. Okay. So similar problem compared to 209, and you proceed like previous problem. The solution says, and adjust last step with the integration between 0 and x, and integrating once more for the fourth time, putting x is equal to 3, you will have the desired result. Question 212 says that, show that sigma r is equal to 0 to n minus 3 cr times cr plus 3 is equal to 2n factorial upon n plus 3 factorial times n minus 3 factorial. So we we know that 1 plus x to the power n is equal to c0 plus c1x and so on up to cn x to the power n, and x plus 1 to the power n is equal to c0 x to the power n minus c1 x to the power n minus 1 times c2 x to the power n minus 2 and so on. Now you multiply both and equate the power of x to the power minus 3. You will get left hand side, which is C0, C3 plus C1, C4 plus C2, C5 up to Cn minus 3 Cn is equal to quotient of x to the power n minus 3n, 1 plus x to the power 2m, which is equal to 2n factorial upon n plus 3 factorial and minus 3 factorial, and left hand side is the left hand side. Question 213 says that, show that the sum of products taken 2 at a time from C0, C1, C2 up to Cn is 2 to the power n minus 1 minus 2n minus 1 factorial upon n factorial times n minus 1 factorial. So I think the last term should be given here. So we have to find sigma 0 less than equal to I less than j times sigma 0 less than equal to j less than equal to n CICJ. Now this we know is equal to sigma ck square minus 2 times sigma CICJ. This comes from the fact that a plus b plus c whole square is equal to a square plus b square plus c square minus 2ab minus 2bc minus 2ca. So you generalize that equality, or we have a plus b whole square is equal to a square plus b square. I read that wrong. Let me correct myself. A plus b plus c whole square is equal to sigma a square, that is a square plus b square plus c square plus 2ab plus 2bc plus 2ca. Similarly, a plus b whole square is equal to a square plus b square plus 2ab. And if you do a plus b plus c plus d whole square, then it would be a square plus b square plus c square plus d square plus 2ab into 2ac into 2ad into 2bc into 2, a square plus b square plus c square plus d square plus 2ab plus 2bc plus 2ab plus 2ac plus 2ad plus 2bc plus 2bd plus 2cd. So it is the general form of that equation. And we know that sigma ck square is equal to 2n whole square, that is 2 to the power 2n, and sigma ck square is equal to 2n factorial upon n factorial times n factorial. So from these two relationships, we know that this sigma will be equal to 2 to the power 2n minus 1 minus 2n minus 1 factorial upon n factorial times n minus 1 factorial. Note that the difference of this 2 to the power 2n and sigma ck square is divided by this 2. Question 214 says that if Sn is equal to C0, C1 plus C1, C2 plus so on up to Cn, Cn minus 1, Cn is and Sn plus 1 upon Sn is equal to 15 upon 4 to find n. So we know that Sn, we are given that this is Sn, so we know that 1 plus x to the power n is equal to this and x plus 1 to the power is equal to this. So we multiply these two and we equate the power of xn minus 1. So we get Sn is equal to C0 C1 plus C1 C2 and up to Cn minus 1 Cn. So quotient of x to the power n minus 1 would be 2n Cn minus 1. So Sn plus 1 upon Sn is equal to 2n plus 2 factorial divided by n factorial times n plus 2 factorial times n minus 1 factorial and times n plus 1 factorial upon 2n factorial. Whole, if you solve this fraction, you will get 2n plus 2 times 2n plus 1 upon n times n plus 2, which is equal to 15 by 4. We solve this, you will get n is equal to 2 and 4. Question 215 says that show that C0 square plus 2C1 square plus 3C2 square and up to n plus 1 Cn square is equal to n plus 2 times 2n minus 1 factorial upon n factorial and minus 1 factorial. So we have these two equations from previous questions. You multiply first equation with x and differentiate with respect to x to get 1 plus x to the power n plus nx times 1 plus x to the power n minus 1 is equal to C0 plus 2C1x plus 3C2x square up to n plus 1 Cnx to the power n. Now multiply this with the second equation and equate the coefficient of x to the power n. Equating the coefficient of x to the power n will give you the left hand side, and right hand side becomes coefficient of x to the power n in 1 plus x to the power 2n plus n times 1 plus x to the power 2n minus 1. Where is the coefficient of x to the power n in this? That is, it is looking in both. So it becomes 2n Cn plus n times 2n minus 1 Cn minus 1, which is equal to n plus 2 times 2n minus 1 factorial upon n factorial n minus 1 factorial. We move on to question 216. It says that show that nc0 times 2ncn minus c0 means nc0 c1 times 2n minus 2cn plus c2 times 2n minus 4cn and so on is equal to 2 to the power n. So we have x to the power n times 2 plus x to the power n is equal to 2x plus x square to the power n. So we take x inside, that is x plus 1 whole square minus 1 to the power n. Now we expand this, we get x to the power n, and we expand this, you get 2 to the power n plus nc1, 2 to the power n minus 1, and so on up to ncn x to the power n. And this becomes nc0 x plus 1 to the power 2n minus n plus 1 x plus 1 to the power 2n minus 2 plus nc2 x plus 1 to the power 2n minus 4. Now we iterate for the coefficient of x to the power n, we get the desired result. Question 217 says that show that sigma 0 less than equal to I less than equal to j, sigma 0 less than equal to j less than equal to n I plus j times ci plus cj plus ci cj is equal to n squared times 2 to the power n plus n times 2 to the power 2n minus 1 minus 2n factorial upon 2n factorial whole square, where 0 less than equal to I less than equal to j less than equal to n. So we have to find this. Earlier we have proven that for I plus j ci cj is equal to n upon 2, 2 to the power. This seems to be 2n minus 1, there appears to be a type of mistake. We figure that out. That should not be too far distance. So it is minus 1. So we are referring to question 189 in this one. So we refer to question 189. We are looking at which problem? we are looking at 217. So look at question 189 solution. That is, if you have not watched previous video, look at the video for 181 to 190. That will have the problem. This is 2n minus 1 minus 2n factorial upon n factorial whole square. And now for this, we have already found this, so we need to find Ci plus Cj. So this we can write as 2n minus I minus j Ci plus Cj is equal to E. Now we add these two. So what we get is 2E is equal to, the sigma will remain, and 2n times Ci plus Cj will be there, which is equal to C0 plus Cj. We have one sigma here, one sigma is evaluated. C1 plus Cj plus up to Cj minus 1 plus Cj. Now this is equal to 2n times 2C0. We put now j is equal to 0 to n plus C1 plus C2 up to Cn plus C0 plus 2C1 plus C2 up to Cn plus C0 plus C1 up to 2Cn minus 1 plus Cn. Now you add all this, you will get 2n square C0 plus C2 C1 plus C2 up to Cn is equal to E, which is equal to, it's not is equal to, which implies that E is equal to n square times 2 to the power n, and you have the final answer. Question 218 says that if 1 plus x square to the power n is equal to a0 plus a1x plus a2x square up to a2n x to the power 2n, show that a0 a2r minus a1 a2r plus 1 plus a2 a2r plus 2 and so on up to a2n minus 2 or 2n minus 2r times a2n is equal to an plus r. So we put x is equal to minus x, we get a0 x to the power 2n minus a1 x to the power 2n minus 1 plus a2 x to the power 2n minus 2 and so on up to a2n. Now we multiply and equate the coefficient of x to the power 2n minus 2r. So we will get a0 a2r minus a1 a2r plus 1 and so on, which is our left hand side, is equal to coefficient of x to the power 2n minus 2r in x to the power 4 plus x squared plus 1. Now we put x squared is equal to y, the coefficient of y to the power n minus, and this should be r. This should be r. And 1 plus y square is equal to n minus r. And that's how we have proven it. Question 291 says that if Pn denotes the product of all coefficients in the expansion of 1 plus x to the power n, show that Pn plus 1 upon Pn is equal to n plus 1 to the power n upon n factorial. So Pn plus 1 would be, upon Pn would be n plus 1 C0 times n plus 1 C1 and so on up to n plus 1 C n plus 1, while Pn would be nc0 times nc1 times nc2 up to ncn. So we separate them out. We write it at n plus 1 C0 upon nc0, then n plus 1 C1 upon nc1, and then n plus 1 upon Cn upon ncn times n plus 1 C n plus 1. So clearly, if you solve this, you will get n plus 1 to the power n upon n factorial. Question 220 says that show that sigma r is equal to 1 to r cubed times cr upon cr minus 1 whole square is equal to 1 upon 12 n times n plus 1 whole square times n plus 2. So we have to prove this. Now, if you evaluate cr upon cr minus 1 whole square, it is n plus 1 minus r whole square. Okay, because cr upon cr minus 1 is equal to n plus 1 minus r upon r. So we have this. Now, it's a trivial matter of applying the summation rule where sigma 1 would be n, sigma r would be n times n plus 1 upon 2. Sigma r square would be n times n plus 1 upon, n times n plus 1 times 2n plus 1 upon 6. And sigma r cube would be n plus n times n plus 1 upon 2 whole square. So you do that and apply that and you will have the result. So with this we come to the end of question 220. Now I will show you my website astrava.org, where you can download the math PDFs from second, third, and fourth link for algebra, trigonometry, and geometry. You can also see the HTML form of the trigonometry book because this is done in DocBook, while these two are done in Contact. Now the download PDF will not contain this date. So when you download, you add this date to the downloaded PDF. And once in 15 or 30 days, you can come and check if the date has changed. If the date has changed, you can download the PDF again and replace the date again. I cannot put the date in the PDF. The reason is that if I put date in the PDF, then all existing link will become invalid when the date will change. And about the question answer, you can come and join me at punjika.astackworkers.org. It is a web application which I have developed for you. It's a question answer platform. So you can use, I have created tags for you: algebra, calculus, coordinate geometry, geometry, probability, trigonometry. And if these tags do not match your question, then you can use the generic tag mathematics. And let's build a community. The whole idea is to build a community where we can discuss mathematics and programming both. So since this is a maths video, I'm promoting it for maths. So please join and ask questions or answer questions. What if you are a specialist in maths, you can answer the questions. Even if you are not a specialist, you can, if you know the solution of the problem, you can answer it, no problem. So that's the request I have. And with this, I will end this video. I hope that you are enjoying the video and finding it useful. So thanks a lot for watching the video. We will meet again tomorrow with 10 more problems. For today, I wish you a great day ahead, and stay curious, keep learning, and most importantly, enjoy.